Let's get into it. Some background about supergraphs. What is a supergraph in the first place? So GraphQL is another kind of API. You have supergraphs, a collection of graphs. So what you have is normally especially in larger organizations, you might have one department that deals with finances, another department that deals with customer service, another one that deals with products, another one with checkout. There's usually a handful of different teams working on different things within organizations. And they have a deployable, let's say, API that they put out, and they have control and ownership over that API. And so they own the data. Ideally, they don't share data between each other. Every team is autonomous and they create their own services. So think microservices owned by different teams, and now you have 10, 20 different microservices. How do you then bring all that data back together into something meaningful, something to create value from? So if you've got an application for, let's say, business intelligence, and you want to get some data from customer domain, you want to get some data from the finance domain, some data from the product domain, tie it up all together. That's a hard task, right? To collect all that business intelligence. Or you might be building an application for users, not necessarily just internal. It might be a public-facing application where it would be a user being able to go to their account page and seeing their billing history, as well as the products they've purchased, the names of those products, the price changes of those products, whatever, a bunch of information on a single page that spans across multiple services. And so when you have this trend these days of microservices proliferating within organizations, it creates the problem of how do you bring all that data back together again. And so that's what Apollo has done an amazing job of with supergraphs. GraphQL in general has the concept of supergraphs, but Apollo is the leader of that. And what you have is this concept of a router. So you have all these microservices. So you make them all into subgraphs. That is that they can now return data to you. And you then put a supergraph on top of them, a router, which aggregates all these subgraphs into a single endpoint. And so that's what the supergraph is. It's a single entry point into all the data for all your system, which is quite a tall order to achieve. For you to have one endpoint that gives you all the data across your whole organization, that's a tough problem to solve. Tough technically, because you have to make subgraphs that can talk to each other, that have the right relationship between each other, I should say, that can then be aggregated by a router. So there's a technical challenge with doing it. But the biggest challenge in what we have seen as the professional services organization for Apollo, and the substance of this talk, is that it's a social problem more than it is a technical problem. And to quickly talk about that, it's because if you've ever heard of Conway's law, an organization follows its communication structures, like the architecture, sorry, I should say, of a system ends up mirroring the communication structures of an organization. And that means that if you have two separate teams, a finance team and a product team, you'll probably end up with two very distinct architectures, one for each side. So it's whatever communication mechanisms and organizational structure you have is going to end up being mirrored in your technical architecture as well. And that means organization creates architecture, which means social creates technical. And so you have to look after the social as much as you look after the technical when you're trying to do something as ambitious as creating a single data point for your entire organization. Right? Just the fact that we're talking the word organization in there means that it makes it a social problem. So then how do you make this problem social? You've got, and this isn't unique to supergraphs, by the way. This is to any transformative technology. Let's say you're bringing in Jira. Let's say you're just bringing in Jira as a tool into your organization. You've never used Jira, and now you're starting to use Jira. There's the technical concern of getting it deployed and so on. And then there's a whole social concern that you have to take care of making sure that everybody uses it, that they know how to use it, what their part in it is, how they create projects, how other people create links between those projects and so on, and assignments. All of that stuff is social. So it's never just a technical problem. It is always a social technical problem. And so what we're talking about here is how do we use NDD to aid that? Narratives are very powerful at giving you a clear picture of what needs to be done. They give you the different parties and their involvement, and it gives you an actual story that you can read that makes sense to humans. And it's time-based sequencing that makes it very easy to understand. And so that technique can be used powerfully for a lot of things, which includes digital transformations, and it also includes this supergraph social aspect. So that's what this talk is going to be about today. Any thoughts, questions before I dive into how practically we do it? Does that all make sense at a high level and explain the problem domain? Yes. Okay. All right. So let me jump into the app and show you something that we would like to solve here. So let's consider that we have a referral program. I don't know what to yet. Let's just assume it's a mobile phone company. And a customer wants to invite their family to their account. So the thing they might do here is they have an email client where the customer clicks on a link in an email campaign that was sent by us. So we just said, hey, here's a cold email to a whole bunch of people, or to our existing customers, I should say, to inform them that we'd like them to invite people in. So this might look something like that. Here's some email client, and excuse the ordering right there. So we have an email client. We have, and the next thing that happens is that they enter the account and they see invite your family link. They click on the link and they're taken to enter the emails of their family members. They click submit, and then the customer has sent an invite to their mother-in-law. Right, so that's basically how they invited their mother-in-law. So then we start to overlay the interfaces as we've seen in other NDD huddles. So we have an email client that enables you to see this email. They go onto this account details page. So this is where they might see the account details. Just open that screenshot up there. It's, let's say, something like that. We've added the UX for it. So there's some account details page over here. And then what we want to see next is that they want to invite their friends and family on this screen. What we're saying is we want to see any pending invites. Maybe I've already sent an invite to somebody. Like you've seen that before. You go to a profile, you're about to invite people, and it says pending invites and whether they've accepted or not, and then any additional invites you want to do. So you don't end up inviting the same person twice. So in order to do that, we've got some specifications that we can add, and we can say in here that given the user wants to send a new friend's invite, when they're on the invite friend screen, then they must be able to see pending invites so they know who's already been invited. Okay, so now we know what we're trying to do. Then what we do is we say, how do we get that data? This is where the GraphQL piece comes in. We don't know exactly who's given us that data, but we know we need that data. So we'll create a query. We'll write up what we call a dream query. The dream query means I'm just dreaming up a query. Give me this data. I don't care where it comes from. It's going to come from the single endpoint that is this one place where I get data from any place in my entire system. So I don't care where it comes from. I just care that I get this data in this shape. So here I'd say friends invites. I want to see the ID of that friend, the invite. I want to see the sender. I want to see their ID and username. I want to see the receiver. So in this case, the sender would be me. Maybe it's somebody else in my family. The receiver would be whoever is going to receive the email, and whether they've accepted or not, and when it was created. So that's the data that I want. That's my dream query of get friend invites. Little mistake there. It should never have get query, always means get. So it's just friend invites. So now that I know that query that I want, I can move on to the next thing. So then I want to do submit invite. And if I click on that guy, then this is a send friend invite. And there are some parameters over here that I would like to send. It's going to look very similar to the query. And there's some types and all sorts. This is technical stuff, but the point is we're starting to define what data we want. All right. First, we have a screen. So there's a user experience that we can look at, and we can annotate, and we can say this is the data that we want. We can write some specifications that further detail the things that we want. And then we can write a query of the things that we want. And that's all a front end needs. In terms of moving on the experience, this is all I need to move on to the next step in the experience. And so then we get into the sending. So this here's the data read. If you remember the transitions, this is a data read and this is a data write. So I'm getting from a system, I want to fetch the pending invites. And then over here, I want to send some data. So what you're seeing is by getting, first of all, the business folks involved to understand the business case, great. Now we can get the experience folks to start writing what they need. So the user experience that came in from Figma or screenshots or whatever you're using as the input for your experience already contains the data that you want. If I look at this invite friends and family screen, I don't have a screen right now, but if you can imagine what that screen would look like, it's that when they're on the invite screen, they must be able to see pending invites. So you can imagine a UX wireframe with the pending invites inside it. We know we want that data. We know we need that data, so it's easy for us to define that data. And so what we can do now is we can invite the relevant people into this session. Say, hey, I'd like this data. Where do I get it from? So at this point, the technical person, a front end might ask a back end person to come engage. And so this is acting now as a placeholder for conversation for all the parties involved. All right, it's like, hey, I need this, but I don't know who I need that from yet. So I might go call them in. I might create a comment and say, Andy, or whoever's in here once this loads up, help me find the right person, for example. And so this is the idea. We want to make this social. We want to bring different people in to start identifying the demands on the data. So this is the demand. And then we're going to talk in a second about the supply of that data. So by starting with the demand, we can start to pull the relevant people in and start creating the social aspect of systems and creation of systems. Now, this happens already. This isn't anything new. It's not like nobody does this. They just don't do it in a formal fashion. They don't do it with a structured approach. And this is what NDD has given us here. It's given us a structured approach to be social about technical systems. By the way, if anyone has any questions or anything, just feel free to interrupt me as I'm talking about
it. Sam, one question I often have is when I'm working with teams on where you've done like a merger and acquisition, and we're actually trying to, one of the first things you're trying to do is actually do that initial integration, which was oftentimes the reason for the integration. So this is a good example where it's like we're trying to bring two customer bases together. So can you maybe just chat a little bit about, as you think about that exact communication problem, because that's entirely a social engagement where teams are trying to even get to know each other. They're trying to actually understand each other's data. Just in this exact example where we were trying to invite company A's customers to company B's services, which is very similar to this kind of promotion. Maybe just talk a little bit about some of the real world challenges just in that initial conversation, maybe that you've seen.
Yeah, absolutely. What a great use case, using this for M&A. That's a perfect use case. And another place where the social and the technical worlds collide, and you need a structured way to do it so that you do it well. You've got how it happens without narratives is that you have a bunch of people who own the integration, and they plan the integration, and they create artifacts around that integration, share that with everybody. Those are the said glue people again. And they organize the information for everyone to consume. And so you're going to have, at a social level, it's what journey do we want to enable so that we can touch these different integration points from the company that is purchasing company B. You got these different data points across these different companies, and you want to merge the data to create a single experience somewhere. That's exactly the same problem. So you would start with a narrative that explains what you're trying to do. You would then overlay the screens that state how the value is going to be achieved by the new value that's going across the different endpoints. And then once you have an understanding of that, bringing those endpoints from the different companies and getting them to talk to each other is the third level of conversation that you would have with the full clarity of the picture. So it's actually identical to what we're looking at here. You do the same thing, but you would just have like as these places where you get the data from, you'd have the two different endpoints from the two different companies. And I think if you then go ahead and add, if the two companies don't have a super graph concept, I would highly recommend that. I would say technically you should start by putting a super graph layer on top of those things to give yourself a single API endpoint. It's actually a very common use case for super graphs to use for mergers and acquisitions for exactly the reasons you mentioned. I believe Expedia works exactly like this. They have a lot of M&A, and so whenever they bring in a new organization, they plug it into the Supergraph. We've also worked with another company in the past, Outside Inc., and they do the same. And so, yeah, does that cover the question, Michael?
Yeah, I think it really does, because I start to also think about many times the user experience and the data questions are just on the front end, and just the user interaction is quite involved when you have two organizations coming together. So it makes just a ton of sense about how to streamline that piece of things. And exactly to your point of how are we handling the merger of the data together. So yeah, I appreciate that.
Yeah. I want to talk about that's when you do it. I want to talk about when you don't do it, something I've seen in the past as well. So what we're talking about here is starting with the business context, moving on to the experience, creating a demand for the data, and then going ahead and supplying it, which I'll get into shortly from different data sources. That is that's the thing that creates the most value from experience by starting with the customer needs, surprise, and then using that to demand data from your system. Unfortunately, that's not how all organizations work. And quite a lot of times it is tech driven or data driven, let's say, data centric. And it will be driven by, we have this data and now we have this other data over here. We're going to combine it in a way that we think makes sense. And now we're going to pass it to the front end, who's then going to consume it in whatever form we created. So that is supply driven rather than demand driven. And let's talk about the perils of that. I'm sure you've seen this, you've witnessed this at multiple companies you've looked at. You log into somewhere like let's just say a large automotive. I don't want to name a specific company. And you go to connect your car to your account, let's say. So if I got a Tesla right now and I sign up and I want to sign up my phone to be the key for my car, it's about a 5-step process and it's done, right? That's because they built it based on the demands of the user. That is, I want to just add my VIN in here. I want to add my email address. I want to go through a couple of security questions. Boom, I've got access. The flip side, when you do it the other way, is that you end up saying, log into this screen. It pings you over to another system where you have to sign in again. Once you've signed in again, you enter your VIN. They send you a letter by post that you have to get the PIN out of, where then you enter the PIN back into the system 3 days later, right? I don't know if you've ever seen that, but I've tried to sign up for my mobile app for a car, and that's exactly what happened. I had to go through that crazy journey. And the reason is because I've worked with said automotive, is because it was data driven. It was creating the data first and saying each system saying this is what we need in data from this other system, rather than being driven by the experience. So those are the perils that you end up with a terrible user experience when you start with the data first instead of starting with the demand from the user side first. So yeah, back to making GraphQL social, making any system social. It's all about bringing the 3 layers of experience together: the interaction, the context, and the system. So here we've started with a GraphQL query that states what we want from the system. Now that we have a demand, and we can go and continue our demands over the top layer. So here we have an invite, and you might have 3, 4, 5, 6 more parts to this experience. We're just keeping it simple for today. So then we say, how do we get this data? There's this thing over here that has to provide us with the data. So if we open that up, and here what we can see is there's an invites. That's what we call a GraphQL resolver. That means it's something that's going to go and resolve the data. And that has a schema. So now we get into the team that just got demanded a query. There was a query over here that said, hey, I want this data. Then this team over here that's responsible for bringing the data for invites will be able to start creating the schema that brings back that data. And so this creates a healthy conversation between different people within the organization, right? This is the technical contract between them, between the query and the schema. And this is not our invention. This is GraphQL. Like Apollo and the GraphQL community has created amazing tooling and structure around that. But how do you make that visible? How do you make the business care about it? As a business, I don't care what's inside of this box right here, generally, but I do care that this front-end team is able to get this data from this back-end team, and I can see the progress on that. I can go like this, and I can say, this one is in progress. And there we go. That's now in progress. I'll just change that color to blue. That's always my preferred color for things in progress. Right there. And we'll say that this one over here is complete, and it's actually waiting for the backend team to finish what they're doing. Oh, luckily, that's green. And this allows us now to start communicating with everybody the state of things. These guys might have their own Jira instance or Linear, whatever they're using to track their work. These guys have their own instance to track their work. These guys are, not tracking necessarily the work, and they're just waiting for reports and demos to see the progress of things. But now you have a way of communicating. You have a way of saying, hey, can we please have a look and see, just what's been completed so far. Okay, now I have a quick read on what's done and what's not. And this can act as an extra layer on top of the 5, 6, 20 different things that need to happen before the final feature is complete. If we look at an enterprise, we're working with Ford Credit right now on exactly this. We'll plan 3 months ahead of time with a bunch of GraphQL queries and mutations and different systems that need to come together. We've created a social rallying on ensuring the overall values delivered. So I can't show you, unfortunately, on this call, but that's the process, is by first understanding what are we building, what's the outcome we want, overlaying the graph aspects onto that map, onto that narrative, and then going ahead and defining where we get the various things from. This really helps you get organized, and it brings both the social and the technical worlds together. I have a lot to plan. Pause for a second.
So question, Sam, as somebody in the business lane and usually the front end lane, one of the things I'm learning with Supergraph is around the schema proposal process. So how is what you showed me underneath invites, how does that relate to that process?
Yeah, I'll get into that in just one moment. I think, Eric, you're also going to ask a question.
I was just imagining how helpful this would be where we're relying on vendors and being able to show everybody this is where this external dependency is, and they can manage those things someplace else, but we can all see where this feeds in and where that traffic is.
Yeah, exactly. So you might do something like that and say, this is actually in the responsibility of external team A. And we're blocked and so on. And there's all sorts of integrations, like from a tooling perspective, that we're going to bring in that actually can bring some of these statuses and labels and what have you from tools like Jira and Linear. So we can surface them here as well in a single point to see. But yeah, that's a great point. So within the Apollo world, now digging further into the GraphQL world, there is the concept of what's called a schema proposal. Let's just look at that real quick. So schema proposals are awesome. What they are is there's a set of statuses for proposals. You can draft them, they're approved, they're implemented, or they're closed. So there's a little workflow that you go through. But what are they? So you have an existing schema. So let's look at this here, invites, and just say, let's look at the query actually. Let's say this query is mostly supported. The only part that is not supported, let's say, is the, also being able to view who sent this. So everything else was in place already, but getting the sender ID and username is not present. So that means we already have the ability to get most of the data, but we need to make a delta, a small change onto that to say what extra thing we need. And so what you do is you create in Apollo land a schema proposal. I'm proposing a change to the schema, a bit like a pull request in code, but here you're saying I'm proposing a change to the schema. The schema is owned by everybody. We all want to make sure we're being good citizens in this overall schema. We're not treading on each other's toes. I'm not going to create a new thing called sender that another team already created. I need to be aware of that. And so the Apollo tooling gives you something called schema checks, which can check that for you. It can take the existing schema. You can say, hey, I want to change this schema by adding sender. It'll say, yep, that's fine. You can do that because nobody else is doing that. And the types that you're using, ID and username, they're existing types. The username is of a specific username type at this company. Yep, that's allowed. You're good to go. Or if there's any errors, the Apollo tooling will say to you, hey, this part of the schema, the proposal you're making is not quite correct. And it gives you an opportunity to change it. So there's a technical aspect of it that the Apollo tooling gives you. And then there's a technical social aspect, which is the proposal has you saw that here, maybe open for feedback. That means, hey, I've opened this. Can you please signal me? Can you give me a review? Should I change anything? And so on. So this is just like the pull requests in GitHub or in Git. So what that means is when I want to make a new query, I can create a schema proposal. So today you'd go and create that in Apollo directly in the Apollo Studio, but we are building in to the tooling the ability to create a schema proposal right from him. So then you can say, this is the query that I want. We know the gap between the query that you want and what doesn't exist, or we can automatically create a schema proposal for you or help you create one. So then we start integrating with Apollo and Apollo Studio, where you can create these schema proposals. And the next thing we do is we wait for that. The team can wait for the different statuses to happen here. before it's complete. There is a piece of magic we are creating. It's called Instant Mock. It's in progress right now, and that is from Zolvio, and that is a way to turn the schema proposal into a mock instantly. So think about it this way. We come here, we define this user journey. We say, this is the demand that we want from the system. But that demand isn't supplied yet. We don't have this supply yet because it's not built. It's still in progress. But the front-end teams want to keep working because they don't want to be blocked by a back-end team that's developing. So what companies typically do is create a mock. But that mock takes about two weeks to produce. Instead, what we're saying here is, once you define the things in here and you create a schema proposal, you can click a couple more buttons and you get an instant mock. That means the front end can go start developing based on this query that was agreed together instantly. And so that's a huge unlock because it turns something that normally takes 2 weeks into a couple of hours. And it makes it a social interaction that created the mock in the first place. It becomes a social interaction between the front-end devs and the back-end devs, trying to achieve this value that's in the middle in the blue, and quickly coming up with a contract between each other that says, hey, I want this data. The backend team says, yes, you can have this data. Let's tweak it up a little bit. Let's make a schema proposal, make sure it works with the rest of the schema. Let's create an instant mock. Front and the backend teams are unblocked to go code independently and then merge it together once they complete. And that's a huge unlock. So yeah, that's what we have in mind for enabling teams on the social and technical aspects, mixing both of those things together when it comes to supergraphs. Questions, thoughts?
Just one. Is Instant Mock live yet?
Not yet. We have a POC that's running. We are running it and we're creating it with Ford directly. So they're pulling the features out of that. We do have it running internally. It's in POC stage in terms of it's working. It's able to go to Apollo, pull in the schema proposals and create mocks and so on. Once we have that functioning internally, then right now in parallel, we're working on making a more robust version that is public consumable, not just POC, but an actual proper project. And so we're hoping to have that done within the next couple of months. At least the first version of an alpha version within a couple of months. And similarly with the integration from here. So right now we don't have the integration between here and Instant Mock. The idea is with Instant Mock that it is something that is open source. You can run it on your local machine if you want. You can deploy it into one of your own servers in your organization. So people are very sensitive about their data, as they should be, and the schemas that go with it. Let's say you're a large organization like Ford. What you do is you pull a Docker image or download this open source project. You deploy it internally in your network, and now you have an instant mock inside your network that you can attach to your internal environments, and your teams inside your VPN can use all of that. What you then do from here is you tie up this narrative app and you connect it to your instant mock, your own hosted instant mock, and then we can start to push data to and from it. And therefore, we're talking to an instant mock inside your network rather than us hosting it and having a security hole.
Last couple questions. Sounds
Any
like
more?
good.
It'd be pretty amazing to be able to take that down 2 orders of magnitude. I imagine people would need some reassurance that the quality of the mock is the same and that there isn't an information loss or lower fidelity.
So on that, if you look at this, like the schema proposal approach over here, let's just look at so if you look at something like this faker, what it does, this is all fake data. Let me just try it over here somehow. Give it a second to load up. So this is all fake data being generated by this library called Faker, and this is completely made up. And it's actually really smart. Like it's a package that it's very widely used, but what it has is, the ability to say, give me a name, and it gives you a random name. Give me an address, gives you a random address. Give me in this language, it gives you some random data. So it's well built in that it can just give you random data. And if you look at a GraphQL schema example, oops. I'll spell today. Example, this will do. What you'll see there is the schema contains things like company, name, address, age, etc. And it tells you this is a string, this is a string, this is an integer, and it's got a bunch of information in here that is quite rich. And therefore, when we use this in conjunction with Faker, we can give you some realistic data on what your API is going to look like. At least if you ask for name, we can give you John Doe. If you ask for age, we'll give you 15, right? So there's a level of realisticness just in the data that you get from the fact that it's fake data. However, that's not enough. If your schema says, for example, in here, get an invite and it says status, that status will be random, but if my journey over here says invite user, my user has accepted, the next query that I do, I'd want to see that status is accepted, right? Like if the journey, there's a sequence here. And so actually that's something we're building in to Instant Mock is not just fake data, but it's also the seeding of the sequence. So the way you do it is you define your user journey. You use Faker to just say, hey, here's my schema, give me fake data. It gives the backend team the fake data, which then they can check. It's basically pre-filling a sequence seed. And they can look at the data and go, yeah, that's not quite right. On the first call, the status should be pending. And then after the invite's been accepted, the mutation's been called, then change the status to be accepted. And so now what you've got is you've enabled a high fidelity mock across the journey by the way of these sequences and seeds. So sequenced seed data. So I'm glad you brought this point up. Yes, this is actually a key pain point that fakes by themselves are not enough. And actually that's what makes mocks so expensive to create. And sometimes it takes 2 or 4 weeks for you to create a mock that can have that fidelity. And now we're saying, actually, you can get that done in a couple of hours, so long as the people in the room understand the sequence of events, which is exactly what narratives give you. And you can now agree how you want to enable that sequence, both at the front and the back end, working together using a mock that can give you that high fidelity.
You just have to not fall guilty to the path of least resistance and say, we let the system generate this and we're going to run with it. You have to use that 2 hours to think critically about the product that it has produced for you.
Hey man, you reap what you sow.
Where my mind goes to is you could, in theory, take that, bring it into a user testing journey, even just for something as like what you're seeing here, which is a referral process. And maybe you're going to actually try a couple of different ways on the UX experience itself, just with random individuals, like a platform like user testing. And you could actually see across a multivariate test, there's 4 or 5 different things we're trying. Using that mock data, you could actually get down to the one path that actually makes the most sense. So you could actually, while the backend team is putting a lot of it, like you could highly compress that learning cycle before using the mocks, Eric, to your point, so that you actually have what's the highest performing referral flow that we can generate as a company before we go do all of the work to put that data together.
I'm trying to find that's an awesome point. I'm trying to find this one library that I found. I can't find it right now. It's basically a way for you to use a GraphQL schema to generate forms and like visualizations. And maybe a future thing we can do here to help with that quicker is that, hey, we know you don't have your full front end yet, but we've got an instant mock, and we'll also give you a sort of an instant mock-up to test the journey. So there's some opportunities to do that kind of thing. But ultimately, your point is spot on, I think, Eric, with this, that how do you validate the realisticness of that mock so that you don't fall over in the practice? I think we can build more and more things around that. So yeah, exciting times with all this enabling teams to go faster. Ultimately, level 1 is get your story, get your narrative. Number 2, understand the demand from a customer perspective, sprinkle in the data, the resolvers, and the schemas, and then unblock everybody to start coding. These all these little wins, a few hours here, a few hours there, a week here, a week there, they're all going to add up. And once you get into the flow of that, what normally takes you a year will start taking you 3 months. Found interest.
Awesome. Do you mind if I steal a couple minutes for announcements, Sam?
Sure. Yeah, absolutely.
Cool. We're going to GraphQL Summit. We will see folks there. DM me if you want a discount link. But that is in October in New York. It's going to be awesome. And then the next couple of the topics are, I'm totally reading off the page right now, sorry. Blue people, finding them, partnering with them, and so on. Discovery is an iterative process and how we go from first draft to source of truth. And then uncovering unknowns through stakeholders, questions, tools, and so on. So the next couple are very much practical examples for enabling people that are trying to do NDD at their orgs and follow on of the existing projects, because a lot of what folks are doing is trying to split off a small chunk and then actually run NDD on it.
Great topics.
Awesome. How do you like them? So we'll see you for the next one.
Indeed. Thanks, guys.
Take care, folks.